Hello everybody, welcome into another lesson. So today we are going to talk about line and angle relationships. The first type we have here are called vertical angles. Whenever you have two lines that intersect, they form what are called vertical angles. So the vertical angles that are congruent, whenever you have diagonal, it goes straight across. So angle 1 would be congruent, and the symbol I'm drawing means congruent. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Angle 3 is congruent to angle 4 there. So vertical angles, they form in such a way that the opposite angle from each one is congruent to each other. So again, angle 1 would be congruent to angle 2. Angle 3 would be congruent to angle 4. Let's do a couple practice problems with vertical angles. Alright. Vertical angles are simple enough to understand. Alright, so let's say this angle's 45 degrees. This angle's x degrees. We don't know the value of that angle. Well, all we have to do is use the fact that vertical angles are congruent. You'll see that x is equal to 45 degrees. That's all you would get. X is equal to 45 degrees. Do one more practice problem with vertical angles, then we're going to move on. I know this isn't drawn to scale, but these serve for good practice problems. So you have one angle that's 148 degrees, you don't know x. Well, we can again use the fact that vertical angles are congruent. You just set x equal to 148 degrees and that's what you get. That's exactly what you get. X is equal to 148 degrees. So I think vertical angles are simple enough to understand. Alright. Now we're going to do what's called complementary angles. We got complementary angles. So you have complementary angles whenever you have two angles that the sum of their measures equal 90 degrees. So here, we have a perfect right angle. This is a perfect right angle. Well, let's say I split this up here. Let's say I split this angle up into two angles. The sum of these two angles will equal 90 degrees. So the measure of angle 1 plus the measure of angle 2 would equal 90 degrees. That's what complementary angles are. Whenever you have two angles that the sum of those two angles equal 90, those are complementary angles. So those aren't so bad to understand either. Let's see. Let's say this one is x degrees. This one's 31 degrees. Well, we don't know x, but we can use the fact that x plus 31 degrees equals 90. Because these are complementary angles. X and 31 are complementary. That means when you add the two of them together, you'll get 90. So now all you got to do is take 31 away from both sides, and you'll get your result. So I'm going to do just that right now. Take 31 from both sides. On the left side, 31 minus 31 is 0. You'll just get x is equal to 90 minus 31. Well, that'd be 59. So the measure of angle X is going to be 59 degrees. And then, in fact, if you stick 59 in for X, you'll find 59 and 31, in fact, add up to 90 degrees. Alright, I think complementary is easy enough to understand. We're going to talk about another type here. We're going to talk about supplementary angles. Alright, let's talk about supplementary angles. So, supplementary angles are when you have two angles that add up to 180 degrees. So, let's create our angles here. It could be more than one. Same with complementary angles. You could have more than one angle in play. But the deal is with complementary, the sum of all those angles will equal 90 degrees. With supplementary, the sum of all the angles given will equal 180 degrees with supplementary. So, in this case, you would use the fact that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So, however many angles you have will equal 180. Heck, if we want to do a third angle, let's do that. Right, that'd be 2, that'd be 3. So, the idea is here, the sum of all three of these angles that we have now will equal, in fact, 180 degrees. So, supplementary angles add up to be 180 degrees. What do we got here? Oh, good one. This is a good one. So, this one is 4x degrees, this one is 8x degrees. Well, what we have to do, of course, we want to find the value of x and ultimately each angle. So, these are supplementary angles, so we're going to take these angles, 4x plus 8x, we're going to set them equal to 180. Okay, so that would equal 180 degrees. Well, 4x plus 8x, that's 12x, would equal 180 degrees. Well, we want to just find x, divide both sides by 12. So on the left side, the 12s will cancel out. You'll have x is equal to 180 divided by 12, that's 15. So if we were just going for x, it would be 15 degrees, but we want to find each angle. So what you got to do is take first the 4 times 15 degrees. You would get 60 degrees for one, which would have to mean that 8 times 15 would equal 120 degrees. So your two angles here are 60 and 120. Because, and that makes sense because 60 plus 120 equals 180. So, those are supplementary angles. And these are the types of problems you have to look forward to when you take geometry. Geometry will come after Algebra 1, but there are lots of problems like this in geometry. See if I could do one more problem like it. We'll just do x and 2x. we'll do x and 2x, okay? So again, these are supplementary angles. We want to use the fact that x plus 2x equals 180. X plus 2x equals 180. Well, x plus 2x is 3x. That would equal 180 degrees. Well, we want to solve for just x, so you divide both sides by 3. On the left side, the 3's will cancel out. You'll just have x is equal to 180 divided by 3, which is 60. So we found the measure of x being 60 degrees, which would happen to mean that 2x is equal to 2 times 60 degrees, which would happen to mean it's equal to 120 degrees. So again, we get 60 and 120 for our measures. So in these types of problems, not only are you solving for x, you're solving for both of the angles. You just simply plug in the value of x for each of these angles and you'll get your values. So those are supplementary angles. Let's do one more here with supplementary. Let's just do some number ones. Let's say this angle's 45 degrees, this angle's x. We don't know x. That's okay. What you got to use is the fact that the angle of x plus 45 degrees equals 180 degrees. So use the fact that these two angles add up to 180 degrees. Just take 45 away from both sides. You'll be able to solve for x by itself. So that's going to be equal to 180 minus 45. Well, on the left, 45 minus 45 is 0. You just got x by itself is equal to 180 minus 45. That'd be 135 degrees. So your answer for x is it's going to be 135 degrees. So supplementary, they add up to 180. All right. Let's talk about a fun one here. Perpendicular lines. We're going to talk about perpendicular lines. What are perpendicular lines? That's a long word to spell. Perpendicular lines are when lines intersect in such a way that they form right angles. So perpendicular lines are lines that intersect in such a way that they form right angles. That's the only time they could be perpendicular, is if they form right angles. So here we have 4 right angles. You can also have perpendicular lines if you have something like this. You could also have perpendicular lines as long as the lines intersect in such a way that they form right angles. They are perpendicular lines. And then you can also use the fact that vertical angles are congruent with perpendicular lines, that each angle diagonal from the other is congruent to each other. And then you have supplementary angles come into play also, where you have 90 plus 90 equals 180. So that kind of ties them all together. Alright, so perpendicular just form right angles. Now let's talk about our final type here. We have parallel lines. So parallel lines are different in the fact that in the fact that they never intersect. Parallel lines are two lines that never intersect at any point. They never meet at any point. The top line is parallel to the bottom line. They'll never meet. They'll never touch at any point. Okay, well that's great. Now what are we going to do with these? Well, there is an idea. This is where it gets fun. If you cut these lines off, that line that intersects these is called a transversal. The line that intersects the parallel lines is called a transversal. If you have two parallel lines that are intersected by a transversal, then we got certain types of angle relationships. Number one, corresponding angles. Alright, so I've set up 8 angles here. Corresponding angles are simply nothing more than each line. Like angle 1 will correspond to angle 2 because it's on the same point of the line right before, the transversal. It's on the exact same point of each line that corresponds. So angle 1 would be congruent to angle 2. And then we have angle 3 would be congruent to angle 4 because it's on the same point of the line as the other line. Then angle 5 would be congruent to angle 7 because it's on the same point of the line as the other line. Then angle 6 would be congruent to angle 8 because they're on the same. Angle 6 is on the same part of the line as angle 8 is on that line. Okay. So, these are called corresponding angles. These are corresponding angles. That's what they're called. When you have one angle that's on the same part of the line as an angle on the same part of the other line, those are called corresponding angles. And corresponding angles, whenever you have two parallel lines that are cut by a transversal, are congruent. Corresponding angles will always be congruent. Alright. Now let's talk about something else here. Let's talk about alternate interior angles. We're going to talk about alternate interior angles. Alternate interior means they alternate. They're on the inside of the line. So, for example, 5 and 4 would be considered alternate interior angles. 6 and 2, those would be alternate interior angles. Whenever you have two parallel lines cut by a transversal, alternate interior angles are congruent. So that means angle 4 would be congruent to angle 5. And angle 2 would be congruent to angle 6. So angle 2 would be congruent to angle 6. Those are called alternate interior angles. They will always be congruent. Then we have a third type here, and it's the final type. I know this lesson's a lot to take in, but this is kind of prepping you for geometry a little bit. Of course, when we get to the geometry course, we're going to talk a lot more in depth about this, but we have what are called same side interior angles. Same side interior angles, such as 2 and 5, they're on the same side. 4 and 6, they're on the same side in the interior between the two parallel lines. Whenever you have same side interior angles, they are supplementary. They're not congruent, they're supplementary. So the measure of angle 2 plus the measure of angle 5 equals 180 degrees. Then the measure of angle 4 plus the measure of angle 6 equals 180 degrees. So that's for same side interior angles, that they're supplementary, not congruent, but supplementary. So angle 2 plus angle 5 would equal 180. Angle 4 plus angle 6 would equal 180. All right. So, now let's go through and let's put this into practice here. Let's look for all congruent angles. Let's start with vertical angles, actually. Let's look for vertical angles. All right. Well, we got lines that intersect here. Let's just start with the top line. Angle 1 is congruent to angle 6 because those are vertical angles. So we got angle 1 is congruent to angle 6 by vertical angles are congruent. Same with 3 and 5. Angles 3 and 5 are congruent by vertical angles are congruent. Angles 2 and 8 are congruent by vertical angles are congruent. Angles 4 and 7 are congruent by vertical angles are congruent. Okay, we got vertical angles are congruent. Now, let's look for corresponding angles. So again, corresponding angles on the same line. And they're on the same part of each line as the other. So corresponding angles, angle 1 and angle 2, those would be congruent. Angle 1 would be congruent to angle 2. What else? Angle 5 would be congruent to angle 7. And what else here? Angle 3 would be congruent to angle 4. What else do we have here? For corresponding, angle 6 would be congruent to angle 8. Alright, so I think we've dealt with all the corresponding angles by dealing with angles that are on the same part of each line being congruent. Let's deal with alternate interior angles. So alternate interior, such as 4 and 5, angle 4 is congruent to angle 5. And then 2 and 6 are alternate interior angles. Angle 2 would be congruent to angle 6. And I think that's all we have for alternate interior angles. Now, same side interior angles such as 2 and 5 and 4 and 6, those are supplementary, so they're definitely not congruent. So we're not going to deal with those. But if you follow the different properties we've been given today, you could find a lot of congruencies. You could find a lot of angles congruent to each other. So, again, remember with parallel lines, corresponding angles such as 1 and 2, because they're on the same part of each line, they're congruent. Alternate interior angles such as 4 and 5, they alternate. They're on the interior between the two parallel lines. Those are always congruent. Same with 2 and 6. Those would be congruent. Then you have same side interior angles such as 2 and 5, and then 4 and 6. Those two are supplementary to each other. They add up to be 180. So that's really it for this lesson. I know we covered a lot today, but it had to be covered. So next lesson we're going to talk about congruent triangles. So it'll be something not as bad. So I hope everyone has a good day. Take care.